Hey algebras, ready to do some homework on word problems and review. It's so important that you circle back and think about all the different parts of this unit. So the first part is, when we started, we talked about, is the given ordered pair a solution? Yes or no? So we're looking for an answer here. Are you going to say, therefore, yes it is, or no it's not? We get that answer by putting this x and this y in to both equations for both variables. In order for it to be true, it has to be true for both. So let's go ahead and check it out. 2 times my x value plus my y value has to be equal to 3. 2 plus 1 is equal to 3. Yep, that checks out. Now let's look at our second equation. I have 1 minus 2 times 1 is equal to negative 1. Is 1 minus 2 equal to negative 1? Negative 1, yes. Alright, so that was Wilbur barking. Everybody can say hi to Wilbur. Yep, he's still barking. Alright, so therefore, yes, it is a solution. Alright, so you do the work for number 2, pause the video, and check back. Alright, I gotta know, how about you? If you put a negative 5 in for x and a negative 2 in for y, be careful about these negatives. You don't want to get tangled up in them. If you are subtracting a negative, that's the same as adding a positive. So negative 3 is definitely not equal to 3. It's not even worth me trying the second one. Once it's not a solution in the first, it's not a solution in the second, and you can save your time. Alright, so let's look at these graphs that we're looking at. When we're solving a linear system by graphing, we're first going to look at our y-intercept, negative 2, and we're going to look at our slope. Our slope here is 1. So remember, our slope is where we rise and then we run. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. So I can connect these dots with my straight edge and then turn to my second line. So my second line has a y-intercept of negative 4, 1, 2, 3, 4, and a slope of negative 1, which means I fall and then run. Now see here how I'm out of graph? Instead I'm going to rise positive but then run negative. Rise positive and run negative. Once I found my intersection, I can go ahead and draw my line. And then I can say that my solution is going to be over negative 1 and down 1, 2, 3. So these graphs here, not quite so easy because I don't have y isolated. So that's an easy fix. So I'm going to add 3x to each side of this one. Positive 3y is equal to positive 3x plus 12. I'm going to solve for y by dividing everything by 3. So I have a intercept of positive 1, 2, 3, 4, and a slope of 1. Again, I ran out of graph, so if I go down and back, notice I can continue my positive slope because those two negative movements make one positive. Alright, let's take a look at my second line. I'm going to add x to each side. And when I add x to each side, I'll have 2y is equal to 6 plus x divided by 2. And that's going to give me y is equal to 3 plus 1/2 x. If I were to write it into slope-intercept form, I would need to put my variable term first. Alright, I have a b of positive 3, 1, 2, 3, and a slope of positive 1/2. So I rise 1 and run 2. Rise 1, run 2. If I go backwards, I fall and go back, fall and go back, and I can see where my intersection for my graph is right here. Circle my intersection, and I can write down my intersection is back 2 and up 2. Alright, let's take a look at the other side of this page. Our back page is where we have solve by using substitution only. Okay, so substitution, no more graphing, but what I'm going to do is I'm going to take one value for one of the variables and I'm going to put it into the other equation. When I do this, because both of these things are equal, instead of writing y, I can write what y is equal to. Y is equal to x plus 3. Now be careful here. It's subtraction, so this is like a -1 that I have to remember to distribute. So my next line is going to be 3x minus 3 is equal to 5. Watch those negatives. 3x and x make 2x minus 3 is equal to 5. I'm going to add 3 to each side of the equation. So 2x is equal to 8. Divide by 2. X has a value of 4. Now that I know what x is equal to, I'm going to go back and put it in and solve for y. So y is equal to that x value plus 3. I'll put 4 in here. So that means that my y is equal to 7. So my answer over 4 and up 7 is the point where those two lines crisscross. So this one, I don't have a variable isolated, and it says substitution, so I have to follow the rules. So I'll leave 3x plus 2y is equal to 8 as is, but I'm going to solve for x by subtracting 4y from each side. So that's going to give me x is equal to negative 4y minus 4. So now that I have that value for x, I can put this in to this equation to help me solve. Alright, so I have 3 times my value of x plus 2y is equal to 8. My value of x is minus 4y minus 4. Negative 12y minus 12 plus 2y is equal to 8. I'm going to combine like terms. This makes negative 10y's minus 12 is equal to 8. I'll add 12 to each side. Negative 10y is equal to 20. Divide by negative 10, and y is equal to negative 2. Now I'm going to go ahead and come up and put that in for my x to solve. So my x is equal to negative 4 times that value for y minus 2. So I'll put that negative 2 that I got down here. X is equal to positive 8 minus 4. X is equal to 4. Therefore, 4, negative 2 are my solutions. So here we have linear combinations. Now, lots of kids like that better because they feel like instead of adding to the problem and making it longer, like we do up here and here, they like linear combination because I get to cancel out a 0 pair. Plus y minus y is equal to 0. So I'm going to add my equations. 2x plus x is 3x. 4 plus 2 is 6. Divide by 3. X is equal to 2. Kids think that that's much simpler. Alright, I'll take x minus y is equal to 2 and I'm going to go ahead and substitute my value for x in, and I get 2 minus y is equal to 2. Subtract 2 from each side. Negative y is equal to 0, therefore y is equal to 0. So my solution is going to be 2, 0. Now at any time you can take this x and this y, plug it in to both of these equations, and see if you get something that's true. That's a good test. You're guaranteed to get all the problems right if you do that. Sometimes there's no zero pair. Sometimes it's not an easy variable to solve for. So what I need to do is think about how I could make something here canceled out. Because my y's have an opposite sign, those are the ones I'm going to eliminate. I'm going to multiply these by 7 and this by 2. Can you tell what common coefficient I'm going towards? 42x plus 14y is equal to 28. My second equation is 6x minus 14y, do you see my zero pair here, is equal to 12. I'm going to go ahead and add these two equations. So that gives me 48x, here's my zero pair, that cancels out, is going to be equal to 40. Divide by 48, divide by 48, and I get x is equal to, let's see, 8 is a common factor, so that sounds like 5 over 6. Don't forget, if you're not sure of this math, you can always go to your calculator and you can say 40 divided by 48 and then do math, frac, and get your fraction that way. We do want to keep the answers in fraction form. Alright, now I get to choose which one of these equations I'm going to substitute in, and I'm going to choose this one. Can you guess why? So 6 times that value for x plus 2y is equal to 4. Maybe now you'll see why. Because I'm going to have these 6's cancel out. 5 plus 2y is equal to 4. Subtract 5. 2y is equal to negative 1. Divide by 2, and I get y is equal to negative 1/2. Therefore, my solution is going to be 5/6 for my x and negative 1/2 for my y. Alright, let's take a look at this word problem. A total of 203 adults and children are at a movie theater. There are 118 more adults than children in the theater. Let A represent adults and B represent children. Which system of equations could be used to find the number of adults? Okay, so here's what's interesting. When we define our variables, let A equal to adults, and we'll let B equal to children. Now I know I have 203 total people of adults and children put together. So as soon as I add A and B together, I'm going to get 203. Obviously, none of these are going to help me eliminate an option. So now we'll have to go here. There are 108 more adults than children, which means I need to add a number to children to make them equal. And I'm trying to figure out a way to express their being equal. So if I add 108 and 118 to the children, that'll be the same number of adults that I have. I have more adults than children. I want to come up with an expression so that I can make them be equal, which means 118 plus the kids is going to be equal to A. This looks good? Nope. 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 So A is the best choice. All right, let's go on to our next page. The difference between two numbers is 3, and their sum is 13. So my first step is going to be to define my variables. Then I'm going to write an equation, and of course I'm going to solve it. And then I'm going to state my final answer. So we'll let x equal my first number, and we'll let y equal my second number. The difference of two numbers is 3. That means when I subtract the two numbers, I get 3. This next sentence here, their sum is 13, tells me what happens when I add them. These are great elimination equations because I'm set up here to have a 0 pair. 1x plus 1x is 2 x's. 3 plus 13 is 16. So I can solve, and I have 8 for x. Once I know x, I can go back and solve for y. I know that x plus y is equal to 13. So 8 plus y is equal to 13. Y is going to be equal to 5. So when I state my final answer, I say, therefore, the numbers are 8 and 5. The rocket coaster has 15 cars. Some hold 4 and some hold 6 people. There's room for 72 people altogether. All right, so we want to know how many of each kind of car. Let's let x equal our number of 4 passenger cars, and we'll let y equal our number of 6 passenger cars. I know total I have 15 cars. I know I have 72 people riding the ride, so there are 4 people in every X car and 6 people in every Y car. So there I have my 2 equations for my system. I think I'll do this one substitution. Y is going to be equal to 15 minus x. So I'll go down and I'll say that 4x plus 6 times my value for y is 72. And I'll put 15 minus x in for there. 4x plus 6 times 15. If you don't know that, we can go ahead and use the calculator. 6 times 15 is 90. Is equal to 72. Don't forget your negative. Oh, I forgot my minus 6x. 6 times 15, 6 times negative x. So it's going to be negative 2x when I combine these 4's and these 6 x's, plus 90. Subtract 90. And I get negative 2x is equal to 18. Negative. Divide by negative 2. And I get x is equal to positive 9. It means I have 9 4-person cars. Then I'm going to go back up here to my equation and say my y is equal to my 15 minus what I got from my x, which is 9. So my y is equal to 15 minus 9, which sounds like 6 to me. So, therefore, there are 9 4-person cars and 6 6-person cars. If I wanted to check that on my calculator, I could, and I'll plug it into here. 4 times the 9 people in each of those cars, plus 6 times my 6 6-person cars. And I'm looking for 72 as my answer. I got it. So I know I did a good job. All right, a store sold 28 pairs of cross trainer shoes for $2,220. Converses sold $70 per pair. Nikes were $90 a pair. How many of each? Okay, so let's let X equal my number of Converses. Let's let Y equal my number of Nikes. I know together I sold 28 pairs of shoes. So this is one of those problems where I need to look at my amount. My number of Converses plus my number of Nikes is going to be 28. My next conversation is going to be about value, and that is always about dollar signs. What did everything cost? So I have $70 for every pair of Converses, $90 for every pair of Nikes, and I ended up with $2,220. So I can see how many of each kind of shoe I bought. All right, I'm going to go ahead and solve for this one. I'll say X is equal to 28 minus Y, and that's what I'll go ahead and put in for this X here. 70 times my value of X plus 90Y, 2,220. And Y, or X has a value of 28 minus Y. 70 times 28, 1,960 minus 70Y plus 90Y, 2,220. 1960 plus 20Y, we combine these like terms, 2220, 2220 minus 1960. So my 20Y is equal to 260 divided by 2 is going to be Y is equal to 130. That means, that's not right. Alright, so I want to make sure I divide by 20. That was my mistake. So when I push my 260, I only divided by 2, and we want to make sure that we divide by 20. I knew it didn't make enough sense to do that, so it's 13 pairs of Nikes that were sold. When I want to come up here and figure out how many pairs of Converses, my Converses are equal to 28 minus my Y, which is 13. So 28 minus 13 is going to be 15. X is equal to 15. So when I write my answer, therefore, they sold 15 Converses and 13 pairs of Nikes. All right, one more page. Do you have it in you? You go ahead and define these variables, set up your equations, and check back in with me. All right, let's check your work. For number 13, I thought this problem was hilarious. We've got a lot of chicken and pigs, and then we're counting the number of legs. So when I look at my number of chickens and pigs, I get 220 animals. There's 2 legs on every chicken and 4 legs on every pig. So we can go ahead and put that in an equation. So here's my system that I'm solving right here. I made my decision to go ahead and solve for Y, and then I substituted that value in for Y, and then solve for X. Once I had a value for X, then I could go ahead and put that in here, and then solve for Y. 180 chickens and 4 pigs. Alright, so Miss Mejia is buying donuts and bagels. So X was my cost of my donuts, and Y was my cost of my bagels. When I wrote my equation 10 bagels at some cost and 5 donuts at another cost were $16.50. People liked the donuts more, so the next day she switched it around. 5 bagels, 10 donuts, $14.25. I used elimination for this one. I multiplied the second equation, the green one, by -2 to get these new values here. And I was able to figure out that one donut is 80 cents. And then I solved back in and got my bagels are $1.25. All right, let's talk about the landscaping company. I'm buying bushes and trees. 13 bushes at some cost, plus 4 trees at some cost. Cost me that much money. Here it is. Remember, when you read these, you're looking for 2 number sentences. So my 13 bushes, 4 trees, 487, first sentence. My second sentence has 6 bushes, 2 trees, and $232. I again used elimination and multiplied this equation by -2. I got -12, -4, and -464 when I added those 2 equations together. 13x's and -12x is 1x. My y's, of course, cancel out. That's my 0 pair. And then when I subtract 464 from 487, I get 1x is 23. So my bushes were $23, and I subbed it back in to solve for my y. Hey, that was a lot of work. Hope you did it. Come to me with questions.